Hi, well, this is going to be the last section for this chapter before you take the test over chapter 8, which is graphing. And what we're going to do is in the last section, we looked at graphing on a number line. And now we're going to be looking at a coordinate system and graphing where we have X's and Y's and graphing inequalities. And these inequalities are linear. In other words, when we do the basic graph, it will form a straight line. Well, let's review here with this number 1. We're supposed to graph y equals 3/5 x plus 2. And one more thing, when I've done going through some of these on paper and pencil, I will, during this video, get on Pearson to show you how to graph these inequalities. There's a couple extra steps you'll need to do than just graphing a straight line. And they'll change a little bit. We'll do a few of them. Because Pearson always changes the numbers when you're doing your homework. But let's go ahead and we're going to just do paper and pencil, and I'll use a ruler. Again, to graph this, most of these are going to be pretty simple to begin with. I'll have the y by itself, which means we'll be using the y equals mx plus b to graph the line, which here the b is a 2, which is the y-intercept, not the x, the y, 1, 2. I know that it's kind of small there. And our slope is 3/5. So the slope is 3/5. And again, it's the rise over the run. And given points, you subtract the y's over the difference in the x's, or you can count blocks. So our rise is a +3, so we'll go up 3, 1, 2, 3. These are small. And to the right 5. 1, 2, 3, 4, 5. From our 2. We went up 3 and to the right 5. And we'll connect it up, and there's your graph. So we did not use the x and y intercept or the fact of plotting points where you would like make the x a 5 or make the x a 10 and plot your points. All right, so that one's done. Again, just a review. What we're going to look at now, though, is number 2. Okay, number 2, we have, I'm going to move it up a little bit. We have this inequality symbol. Well, to begin with, we're going to find our 2 points, just like we did here. These 2 points, we're going to ignore the inequality symbol. We're just going to think of it as an equal sign. So we're going to plot our points as if it were y equals 1/8 x. We'll use the y equals mx plus b. And here we have y equals, we'll just keep it as an equal for right now. And the b is +0. That's a weird 8, isn't it? All right. Now we'll go to 0 on the y-axis. It's +0. And again, we're using the method because the y is by itself. We're going to go up 1 and to the right 8. We're going to go up 1 because it's positive, and then we'll go to the right. 1, 2, 3, 4, 5, 6, 7, 8. Above the 8. Okay, now it's different as far as if it has a bar, just like on the last section, if it had the bar, it included it. And if not, it was a parentheses. Well, here, when you're connecting this line, if it's equal, it means solutions fall on the line. And so you have a solid line connecting it. So it really looks no different than if it were an equal sign. But if you don't have the bar, so if you have a less than or equal to or a greater than or equal to, these will have a solid line connecting your 2 dots. However, which means that the solution can fall on the line itself. You can find solutions to that inequality on the line. However, if it's just less than or greater than, you'll have a dashed line. which means, and we'll do some of those, which means the solution is not found on the line. And again, there's a place in Pearson where you can do the dashed, whereas this would be a solid, and it could fall, but that kind of gives you an idea. Here, the solution can be found on the line. With these inequalities, you will have a dashed line, connect it with a dashed line, which means the solution is not. Now, it's an inequality, so we'll have more than just solutions on the line, because let's say I'm going to pick a point, and I'm going to pick this point right here. This is the point 8, 0. If I were to put 8, 0 into this inequality, does it work? Is it true? Well, let's do that. I've got y less than or equal to 1/8 x. I'll put in 0 for the y. Is 0 less than or equal to 1/8 x is 8 times 8? All right, is that true? Well, I'm going to put my 8 that I put in, because I'm multiplying it to a fraction, I'm going to put it over 1, and I'm going to reduce it. Is 0 less than or equal to the number 1? Yes, it is. Even though this point is not on the line, it's still a solution because of the inequality, which means you're going to have to shade where the solutions are found. Because if I were to pick a point up here, maybe, how about the point 0, 2? Let's pick this point 0, 2. Will a point up here work, or is it a point, or just down here? I'm going to put 0 in for x, and I'm going to put 2 in for the y and see if it's true. So I'm going to have 2, I'm putting 2 in, less than or equal to 1/8 times 0. So I'm putting in 0 for the x and 2 for the y. Is 2 less than or equal to 1/8 times 0 is 0? Is that true? Is the number 2 less than 0? No, it's not. That tells you where you can shade, and there's an easier way. I just kind of wanted to show you why. But here, all of our solutions are below the line. Okay. Now, rather than actually putting in points to determine are our points below the line answers, including the line, or are the solutions above the line, including the line? Here, it's right here. That kind of tells you if you're going to go above or below the line. You want the y values that are smaller than the line itself. Y values that are less than the line are found below the line, so you would shade below. So the key is to look at that right there to see whether or not you go below, or if you have y's bigger than or equal to whatever your line is, this one you would shade above your line. All right, and we'll practice that idea for a solution. But to see if a point works, you can put it in just like we did before and see if it's true. Let's practice that idea real quick, and then we'll do some more graphing. So let's practice, putting in a point and seeing if it's true. Is 3, 5 a solution to the inequality? Well, here I'm going to put 3 in for x plus 2 times y. The y is 5. Is that number less than 20? Is that true or not? Is this a solution to that? Well, 9 plus 10, is that less than 20? Is 19 less than 20? It's true. All right, so that is a solution. So I just kind of want to practice in case you're not sure, wow, do I shade over here or do I shade over here? Well, you can pick a point in that section and put it in to see if it's true or not. Let's look at one more. Let's just swap them. Does it matter if you swap these? Now the x is 5. These are in alphabetical, x, y. So 3 times 5 plus 2 times 3. So I put the 3 right there. Is that less than 20? Is 15 plus 6 less than 20? Is 21 less than 20? Whoa, I gotta put a 2 there. That's false. So this is not. So this is a yes, and that's a no. All right, because it's not true. 21 is not less than 20. All righty, but 19 is. So this point is a solution, whereas this point is not a solution. So when we have a lot of solutions. Even with a line, it's just, here, because of the equal, the solutions are on the line only. But an inequality kind of expands our solution. We have more than just what's on the line. In this case, because of that bar there, we have what's on the line, and anything below the line will work. And I picked a point and put it in, and sure enough. So let's practice graphing, all right? And I have a few more, and then we'll look at Pearson. This one is a little bit better graph than that last one. That blocks are really small. So we're going to graph the inequality, and it's already in the form y equals mx plus b. So this first step, when you're finding the 2 points you want to connect, it's just as if that were an equal sign. So we're going to go to a -2 on the y-axis and make a dot. The y-intercept is still a -2. The slope is the number in front, and the slope is a 1, which means the slope, we put our whole numbers over 1, so we create a path. We'll go up 1 and over 1. Okay. Now we have to pay attention to the inequality, because we need to know our solutions found on the line, which means it has a bar, or they're not on the line. Well, it doesn't have a bar, which means they're not found on the line itself. So we do a dashed line, which means the solutions are not there. I guess I could put a dash there. All righty. So where are the solutions? Are they down here? Are they below the line? Or are the solutions above the line? Okay, these are below, these are underneath the line, and these are above the line. That seems to be a hard concept for some people. And try not to make it too difficult. But here we want the y's. These are the y values. We want these y values to be bigger than the line itself. This represents the line. So the y is going to be above the line. So we'll shade above, and I'll show you how to shade on Pearson. Is that true? Did I shade in the right spot? Well, let's pick a point, and man, if you can, pick the point 0, 0. That's a really easy one. If you put 0, 0 in, it should be true, because it's in our shaded area. And we're saying, okay, any point over here is going to work. All right, it is a solution to that equation. So let's pick 0, 0. So does 0, 0 work? If it does, then they all work. So y is 0. X is 0. Is 0 bigger than 0 minus 2 is a -2? Is that true? Is 0 bigger than a -2? Yeah, it is. All right. So you shaded it correctly. So you have greater than, you're going to go above the line. Okay. All right. Let's try another one. Here, again, we go ahead and we use our slope-intercept form to graph. We have the y-intercept, -3. So we'll go to a -3 on the y-axis, make our dot. Our slope is 1, which happens to be the same as the last one, 1 over 1. From the -3, we're going to go up 1 and over 1. Slope of, and it's a positive, so that's why I'm going up. If it was negative, I'd go down. Oh, now before you connect it, is it dashed or solid? You do have to look at the inequality. Without that equal under there, it's dashed. That means the solution is not found on the line itself. Okay. Where are the solutions? They're not on the line, we know that. So where are they? Are they above or are they below? Looking at this, we need the y values that are bigger than the line. So that means y values bigger than the line are above the line. The greater is going to be above. Okay. If you're in doubt, pick the point like 0, 0 and see if it works. So we're going to put 0, 0 in and see if it's true. The y is 0 and the x is 0. Is 0 greater than a -3? You bet it is. So it's true. You're good. All right. Let's look at another one. Oh, it's another little graph, but oh well, we'll just deal with it. The blocks are little. Okay, here, y equals mx plus b, our slope-intercept form. The y-intercept is 10, and the slope again is 1, but oh well. So we're going to go to 10 on the y-axis. 9, 10, 11, 12. So there's our 10. So each block is 1. I just had to double check and make sure. Our slope is 1, which is m equals 1 over 1. So we're going to go up 1 and over 1. But before you connect it, oh, look, it has that equal under there. So that means the y, you can have, the solutions are found on the line as well as above or below. So we have a solid line here. Perfect. But there's more solutions. And will the solutions be found below or will they be found above? I want the y values that are less than the line. So we want y's that are under the line, and that will be below. All of these y values are less than the line itself. So we want y's that are under less than. If in doubt, look, put in 0, 0. See if it works. 0 less than or equal to 0. Is 0 less than or equal to 10? I'm just putting in this point here. If this one works, they all work. That's true. 0 is less than 10. So here's solutions over here. All right, let's try some more. This is pretty much all we're doing. Oh, guess what? It's a little bit more complicated because when we're graphing these, we're not going to use the slope or the intercept method, where we find where we make the y 0 to see where it hits the x-axis, and we make the x 0 to see where it hits the y. With inequalities, get your y by itself because it helps tremendously with shading. So we're going to have to practice getting the y by itself. Now on all of these, at most, it will be 2 steps to get the y by itself. We're going to move the x first, add the opposite. A minus y is less than or equal to a minus x plus 9. I have to keep those separate, and I am putting the x first so that it matches this guy right here with where we have the x first. Okay, we have to get rid of that negative in front of the y. So we're going to divide everything by a -1. But from the last section, I know that if I divide by a negative, I have to flip the inequality. So it took 2 steps, this, and then we're dividing, but we have to flip the inequality. A positive x, negative over a negative is a positive, and these cancel, so you get your positive y. Positive x minus 9. And now we can graph it. Their slope is positive 1 again. So we have a -9 on the y-axis. Excuse me, did I say positive 9? -9 on the y-axis. Our slope is 1 over 1. So we'll go up 1 and over 1. But now we have to look at the inequality to determine if it's a solid line or a dashed line. Well, looking at this, you have that bar underneath here. That means equal. So it can be equal, which means we'll have a solid line, and the solutions can be found on the line itself. So it'll be a solid line. And it looks like we want y values that are greater than our line here that we just did. We use this to find the line. So we want y's above it, and these y values are greater than the line. So we want y's bigger than the line. So you go above. If it's greater than, it's above. If it's less than, it's below. So if you forget to switch this because you're dividing by a negative, it will affect your shading, is what will happen. You know, the picture here will be the same, but your shading will be wrong. So kind of watch that. Let's try another one. I'm kind of disappointed in that. Okay, let's try number 10, because number 9 is just like number 8. All right, here we're going to get the y by itself. So we'll start out with 5x plus 6y. This is a good skill, is to be able to get the y by itself. Subtract 5x. That'll always be your first step, is to bring the x over, less than or equal to. I'm going to put the minus 5x first and the plus 30 second. You can't combine them because 30 does not have an x. The last step, I'm going to divide by a positive 6. Well, since I'm dividing by a positive 6, I don't flip the inequality. We have a negative 5/6 x. So I'm writing this as a fraction in front because it represents our slope. So I wrote it as a number in front. It's not wrong to have a minus 5x over 6. This looks better, so we know what our m is. Plus 5. So now we're ready to graph. The hard part's over. We'll go to 5 on the y-axis. So we'll go up. Yep, they're all 1. Okay. From there, our slope is a negative 5/6, which means we're going to go down 5. We'll go down 5, 1, 2, 3, 4, 5, and to the right 6. You don't want to go down and to the left, because that would be negative over a negative, which is a positive. So we're going to go down 5 to the right 6. You could go up 5 and to the left 6. Just one of them is negative. Down and to the left represents a negative. So we're going to go down and to the right. Okay, once you've determined those points, you have to look at the inequality now. Before, we've just kind of ignored it, other than the fact that if we divide by a negative, we had to have flipped it. We want a solid line because that's equal. So that means that we can have answers that are equal to the line or on the line. It's solid. Now, do you shade below the line or do you shade above the line? Well, we want y's less than the line. So this is below. We're going to shade below. We want y's that are less than the line. See, pointing towards the lesser numbers. The y's are less. All of these y's have less values than the line itself. These y values are less than the y values on the line or the y's above it. But just in case, let's say you're not sure, do I go below or do I go above? If it's less than, it's below. If it's greater than, you shade above. But in case you're still not quite sure, let's put in 0, 0 and see if it works in the original. 5 times 0 6 times 0. Is that true? I put in the point 0, 0. And we want it to work because it's in the work section. So we come up with 0 less than or equal to 30, which is true. So if this point works, then all of them in that section work. Try not to make that shading harder than it is. And if you still have trouble with that, you can let me know. Let me see if there's another one I'd like to go through. Let's do. All right, let's go ahead and let's look at number 12 here. And then we do need to look at 13 and 14. They're a little special cases. Awesome. All right, again, we're going to get the y by itself. We're dealing with an inequality. If this were just an equal sign, you could use the slope, the intercept method to find out where it hits the x-axis. You make the y 0. To find out where it hits the y-axis, you make the x 0 and solve it. But we're not going to use that method. We're going to solve it for y. It helps us so much with shading. We want that by itself, so we're going to get rid of the x. That's always our first step. We'll add 3x, the opposite. 4y is left on the left, less than or equal to 3x plus 12. And I'm going to put the 3x in front of the 12. And you don't have to. 12 plus 3x is not wrong. It's just kind of easier to see what the b is and what the slope is if you put the x first. All right, now let's divide by 4. That'll ultimately get our y by itself with a 1 in front of it. Do you flip the inequality? Well, you divided by a positive 4. That was not a negative. So that means we'll leave it. We have 3/4 as a slope. It's the number in front of the x, 3/4, plus 12 divided by 4 is 3. So it's going to hit the y-axis at 3. Let's go to the 3 on the y-axis. 1, 2, 3. This is a nice little grid here, nice big blocks. From the 3, we're going, this is our slope. Rise over run, we'll go up 3. There's room. We'll go up 3 and to the right 4. 1, 2, 3. 1, 2, 3, 4. Okay, there we have it. I'm going to tell you something. What happens? You see, I was able to make my point. Oh, I kind of skipped this step. Is it solid? I forgot to talk about it. This has the bar underneath, so it is solid. If it didn't have that, you would have done a dashed line. So you do have to pay attention to that idea. So if my math lab doesn't like your answer, there's a couple of things you can check, and that would be one of them. Should it have been a dash line? Should I have shaded above instead of below? But you see, this point fit on my grid. But what happens if it didn't fit on my grid and my slope was a positive 3/4? Well, what you can do is you can go a -3 over a -4. So that means you would go down 3, 1, 2, 3, and to the left 4, 2, 3, 4. Close enough. So you can make them both negatives, which in reality is a positive. And that's if it doesn't fit. Otherwise, I go up and to the right. This would only be if it didn't fit. You couldn't go up enough. All righty, now we have to shade it. Well, let's look here. Looks like I want y's below the line. Okay, so I'm going to shade below because the y's below the line here will work. If that would have been a greater than, I want above, and I would shade above. And again, you can take this point 0, 0. It's in the shaded area, so it should work. Put it into here, put in 0 for x and 0 for y, and it should be true. Is 0 less than 12? You bet it is. So that one works. Okay, so I hope that kind of makes sense. Again, that's, it's very similar to your homework. Your numbers here will probably change. Just watch the shading, and if it's really confusing, let me know. But there's a couple of special cases that I wanted to talk about, and then we're going to look at Pearson and how to do the shading in the dashed line, with Pearson. What happens if I have x is less than 6 on here? How do you graph that? Well, I know from our previous lessons that if I were to graph this, it's a vertical line. It's going to hit the x-axis at 6. So I'm going to have this vertical line at 6. It has an undefined slope. Now, is my line going to be dashed or solid? Well, because that bar is there, it will be a solid line through the 6. That means all the x's have to be 6. So that's that graph. All right. But x's that are less than 6 will also work. Not just the ones on the line will work. This would be like 6-1, 6-2, 6-3. Any point over here where the x's are less will also work. So all of these x's that are less than the 6 will also work. Any point that has an x coordinate that's less than 6 will work. You know, this point right here, the coordinate 2, -2. As long as that x is less than 6, it'll work. So it's over to the left. Less than would be over to the left, smaller values. All right, let's look at another one of those. Okay, this one happens to be the same, but that's all right. I think I might change this one in case they change it on yours. I'm going to graph x is greater than 4. Right, because yours might be different and I want you to look at a less than and a greater than. I'm going to graph this, which means I'm going to go to the 4, and it's going to be a vertical line, has an undefined slope. And the reason the slope is undefined is because if you were to take the difference in the x's or the difference in the y's, which would give you like maybe a 5, over the difference in the x's, you always get a 0 here when you take the difference in the x's. So that would be undefined. So the slope is undefined. It's going to be through the 4, the vertical line through the 4, but it's going to be dashed because we don't have that equal sign. So I'm going to dash it. So our solutions are not found on the line itself. Our solutions are the x's that are bigger than 4, which is over here. They're larger. These x values are larger than the 4. So that's how you would graph a larger, and that's how you would graph if you're missing that equal sign underneath. Okay, let's do some y's. Here, y's greater than a -6. This is a horizontal line when it's missing the x, so we have a y -6. It's going to go through the -6 right here. So horizontal line is going to hit the y-axis at a -6. Do you want a dashed horizontal line or a solid horizontal line? Well, because we're missing the bar, we're going to do a dashed horizontal line. Now, that means that you can't find solutions on the line itself, but you can find, you want y's bigger than a -6. Where are y's larger than a -6? And that would be above. So if you were to put in any point here, let's say this point here, 4, 3. If you were to put that into here, there's no x, so that means you just put the 3 in for the y. It's true, 3 is bigger than a -6. So that section works. Let's try another one. Last one for this chapter. Last one. That'll open things up. And again, I have y's greater than a -2. Let's go ahead and let's change that and look at y's less than a -2 and see. It's a horizontal line, and we're going through a -2. The slope is 0. It's flat. And this is dashed through the -2 because there's no bar underneath it. So we'll do a dash, and then we're going to look at Pearson here and how to shade. It's not hard. We want y's that are less than the -2. Less than will occur below. So that's the section for your solutions. All right. So now what we're going to do is we're going to learn how to do this with MyMathLab and the buttons that you'll have to push. All right, so what we have here is Pearson. Some of the problems will be similar to yours, and we're going to look how to graph this right here. We'll go through a couple of them, and I think you'll have it. We'll go ahead and we'll use our pop out, and when it pops out, you have to choose what it's going to look like. You know, it's not going to be a parabola or an absolute value. It's going to be linear. It's going to give you a choice on whether or not you want to make it a solid line or a dashed line. Well, let's go ahead and we're going to do a line, and it will be solid. All right, now we'll go ahead and go to our 0 because that's the y-intercept. It's a +0. Click. The slope is 1/6, so we'll go up 1 and to the right 6. 2, 3, 4, 5, 6. There we go. 6, 1. All right, so it's dashed. I believe now, let's see, let's go ahead. Let's say you made a mistake and you wanted it dashed. Let's see if we push this, if it'll make it dashed. Yep. So you can always change that after you've graphed it. Well, we want solid because of that bar, that equal under there. Now we need to shade it, and that's what this little paint bucket is for. What we'll do is we know we want under the line. We want y's less than the line itself. The 1/6x represents the line. So we want y's less than, so we're going to go below the line, which means we're going to go, you press your paint bucket, and you go down to the section you want, anywhere in this section, and click. And it's shaded. And now, oh, edited coordinates, that's all right. And then you can save it, and you can check your answer. Still has that paint bucket there, but it liked it. All right, let's choose another one. Okay, that's do the points work. It's kind of in a strange order there. Okay, let's look at this one right here. We'll go to a -5. Well, let's go ahead and do our pop-up here. It's going to be a line, and like I say, you don't have to choose dashed yet. You can always do that later, but looking at this without the bar underneath it, it will be dashed. I can go ahead and change it right now. So I picked it linear, it's going to be dashed. We'll go to a -5 on the y-axis. And there's one of our points, -5. Yeah, but they're on the right of the pop-up at 0, -5. Click. Our slope is 1/1. I had plenty of practice with that. Up 1/1. Click. It made it dash because I chose it. Now you could do the dash now if you wanted to. Now I have to shade it. So my paint bucket, I'll click my paint bucket here, and I'm going to shade. I want y's larger than this. The x -5 represents the line. I want y values above that line. And these are above. All of these y values are bigger than the line, like 0. All of these are above it. So I'll take my bucket of paint, I'll click anywhere in this region, and it'll shade it for you. Save it, and then check your answer. All right, so there's a quick thing on how to make them dashed or solid and how to do the paint. If any other further questions, just let me know. That pretty much does it for this section. All right, bye-bye.